actually like determining a winner and things like that. But you can start to see probably how it's done. So first thing is, just to get a sense of like the relations I have. So I have, like a board has one game, a game has one board, a board has many squares, right? A square belongs to a board. A game has many users, right? That would be the two players. Right? And a square has one turn, and like a turn, has one square, and then like a user has many turns, right? And a turn belongs to a user, right? And then so you can see that, but basically, right, also remember like through these relationships, I can basically get to anything. So if I want to see like all the squares in a game, it'd be like game.board.squares. And if I want to see all the turns in a game, it would be like game.board.squares, right? And then map through the list of turns, right? Just iterate through all the squares, and then for each square, call square.turn. You can get all the turns from there. So you can see this, if you look at the code, you can see, okay, like here's the board. I guess there's nothing stored directly on the board. My guess is it's stored on the game, right? So here's the board, right? A game has these two users, and then it has this board. And you can see I have a method. I don't really know why I need this method for board, but I do, because I guess I'm just storing the board ID here. And then here you can see all the turns, and you can see that's what I'm doing, right? I'm calling self.board.squares, and this is giving me a list of squares, and then I'm iterating through it for each square in the list of squares. If there's a turn, like return it. So when this returns none, then you don't, there's nothing's going to be returned. But where this actually, somebody has made a move on that square, it will return it. I don't know why I'm doing this. Oh, I guess this is if we want to see them in order, So I guess there's this thing called turn number on each turn. So I'm just sorting it by the order that the turn was actually made here. And then, the turn thing is actually probably the key thing. So you can see that has the square and the user. And because there's only, I'm creating a new set of squares for each board and for each game, this is associated with a game. So I should be able to call game.turns, right? That's what I'm doing here. Call game.turns, and that returns to me the list of the turns. And then once you get all those turns, you can see, okay, which user, right, made the move, right, on that square, right, on this specific square for that game. Other things, let's think about it. Oh, the board is kind of interesting, right? Because you can see how this stuff is going to play into calculating a winner. Is I wrote something called rows, which gives you a list of all the rows, and then this is columns, which is a list of all the columns. I mean, I Googled how to do, if you're like, well, how would I know how to do this? I Googled, how do I group by a specific attribute in Python? And it told me this. And then same thing for columns. But I'll show you a little bit more about how this works, the rows and columns. But if you think about why something like this is useful, I can go through potentially each of the rows, look at what turns there are on each one of those rows. Did it, for the first row, are all of the squares in that row occupied by the same player? If they are, then we have a winner, and probably go through one by one each set of rows. So you can get you're kind of still confused about this function. You can get a sense of it a little bit more if you look at the test. So here you can see, test that a board has 3 rows. So I build the store, wherever that is. I guess it's in the index file. And then, but we can assign, right, this is a dictionary. Call play game, and then gameplay, assign to gameplay the board. And then let's just take a look to see what our board.rows does. I might already have it up. Okay, so I actually have it up. So I just hit the breakpoint. So we're right here, okay? And you can see I call board.rows, and that returns a nested list, right? And this is the first, and you can see it's a list of 3 rows. So this is the first row, and then this is the second row, right? And then this is the third row, okay? And then you can see that it may be a little bit better because I do board.rows square bracket 0. So that just returns to me the first row. And notice what this is. Each element here is a square object. And then you can see kind of that this works because in each square I have the x and y coordinate. So you can see this is the x and y, right? So 1, 1, 2, 1. Yeah, so y is staying the same, right? If it's the first row, the height stays the same. So 1, 1, x, this is the column, this is the row, right? 2, 1, column, middle column, top row, third column, top row, right? And then you can see for each one of these, if I want to say like, who's the player on each one of these things, you know, on every square in this row, I can go through all these, do board.rows square bracket 0, and then call square.turn for each one. If this is all the same and not none, right, then it's a win, right? So you can see once we set up this pretty well, like the data modeling pretty well, then determining, you know, we could just use the all function. Like, are all these the same? Actually, why did it say false? I'm surprised. Maybe because with none values, I'm not sure if that just returns false, right? But doesn't if we do all of like 1, 1, and 1, right? That returns true. So that actually works really well. I guess it's just when it's all none values that all. Let's take a look. Yeah, that returns false. But if they're all like the value of x, you know, right, then that would return true. So this actually would work well. We could just go through each one of these rows, do it for the first row, change this to a 1, do it for the second row, right, change it to a run, do it for the third row, right, or, you know, for basically the length of the rows, and check that all of them have the same value. And if they're none, it gives us false. If it's true, you know, if it's anything else, it would give us true, and that would tell us, you know, that we have a winner. And then we have something very similar for columns. In terms of, so now you can see like how rows works, right? It returns like each list is a specific row, as opposed to with columns, each list would be, you know, a specific column. In terms of how it's implemented, I don't know why I needed to sort it, but I did. But all I really need to do is do this group by this attribute. So I'm grouping by the y attribute. So this means all of those with the y value of 1 will be in the same list, and all those with the y value of 2 will be in the same list, right? So that's what's happening here. All those with a y value of 1, right, are in the same list right here. And then you can, if you want to look at this for, you know, the second row, now you can see we all have, right, that's right there. And then for columns, it's just the opposite. For columns, let's just take a look, right, for columns now, this is the same, right, this is the x value. The x value is 2, so this is the middle column, right, first row, middle column, second row, middle column, third row. And again, the way that's done is just we're grouping by the x value. Okay? So like by having, you know, you can see that these methods really help me. You know, I wrote a find square method, right? Because basically like if someone wants to input, you know, where they want to make their move, they can just give me the y value and the x value. And then I find that square, I just do rows, called dot rows. If I do board.rows, right, this returns to me, you know, a list of, right, this is the top row right here. And so if they tell me the x and y value, I can do, I think this might, it's the y, yeah, it's the top row. So they tell me the y value, this will give me everything in the top row. And then they give me the x value, this will give me the column, right? So the middle column would be here. So let's just do one more example. Let's say they give me the X and Y value, they want the middle row. That would give me the 1, right? So they'll put in 2 to my, the second thing, because of indices, it's really a 1. And then now they give me, okay, I want the third column. So that would be the X value, right, is this 2 thing. And then this is, when they make their move, right, they kind of like, this is the square that's going to be associated with this turn, right? We'll set the square ID here, okay? So part of the point is, like, once you set up the modeling really well, like, the logic starts writing itself. I think, hopefully, I bet you if you all, like, worked with this code base, and you're free to, give it a shot, like, just write out the game logic for this code base. Chances are it won't be that, it'll be challenging, but you'll be able to see a path forward and do it. And the code hopefully will look a little cleaner. So you guys are free to explore this. One other thing you can see is, like, this is part of the reason why tests are just very useful, is hopefully they tell a story, like play the game, build the board, right? And now you can, explore this function ideally, and you can see the result, right? And then find a square, like how does find a square work? Okay, we build our board, we do the setup, now we put in 1, 2, and we see that this is right, this tells a logical story, that we found the correct square because it has these attributes. Test turn, so I'd say, like, when part of why I'm going through this is so that you can see what it means to navigate a new code base, right? We have this make a turn function. So what does that do? Let's take a look at gameplay, play game. Let's see, I'm gonna go over here. So it's in the services, play game, and then make a turn. I guess we get the board, we find the square, and then we create a turn. So we get the square here, right? They give us the X and Y value. We find it, we get the correct square, then we input the square and the user. So this is how someone makes a turn, is we just need to populate this thing, and so the user gives us the X and Y value, right? And we then find the corresponding square, and then we create a turn, the square and that user, and that effectively stores that the user is occupying that. All right. I don't know, questions about, you're free to explore this, and then, or if you want to just keep working on your code base after having seen this, that's fine too. But any questions before I put you back into breakout rooms? One thing just to emphasize is notice, like, once you have the data modeling down, like, it's like you model the data, right? And you write out the relations, then it just becomes easier to do fill in the rest of the logic. Okay, so that's one thing. The other thing I wanted to point out is, remember, like, with SQL, we're trying not to store our data, like, multiple, like, our data in more than one place. Meaning, if we have, just to go back to, like, an original example, if it's like an artist has many songs, right, we store the artist ID on the song, right, on the song, but we don't also store it on artist. I'm following that same thing here, and it just makes things easier. You can see I have a board, a game has a board, and here I'm storing the board ID, but if you go to board, right, I'm not storing game here, okay? Instead what I do is I write a function, right, to find it. Why do I do that? This way I don't have to remember to keep updating every like object in my code base every time I change something. I just update one thing, right? I just update this guy, this is how I associated it, and everything else just calculates the association from a function, okay? And that tends to make things a lot less complicated, right? This way I don't have to remember, okay, I have to update like 7 different objects now that I've associated, this game with this board. Just have the association stored in one place, and then everything else can just calculate it, right? So if I go to board, it just says, okay, go through all the games, look for where the game.board ID is this existing board ID, and that's the game. Cool. All right, I will I put that code base in Slack. You're free to look at it. And then, yeah, I'll put you all back.